Hello guys, so for today's video is we'll talk about the patterns of nature and types of patterns, and we will show it to you guys some example of patterns in our surroundings. Before we proceed, we will introduce to you guys ourselves. I'm Maeve Cabahon.
I'm Alfredo Edson III. I'm Benjamin Emena. I'm Mark Lawrence Alibatu. I am Wilford Vitabino. I am David Juan Doble.
I am Nash Alexander Ito. And I'm Joel David Di Villacapa. And we are from
BSIT 1D.
Hello guys, I will be discussing one of the patterns in nature, which is symmetry. What is symmetry? Symmetry in nature means that something is balanced and look the same on both sides when divided. It's like a mirror image. Patterns in nature such as the wings of a butterfly, the petals of a flower, or the shape of a starfish often show symmetry. So, flowers often have petals arranged in a circle. So showing it has radial symmetry. So symmetry in natural pattern is how nature creates order and balance, making things look beautiful and organized.
Next, the spiral. A spiral in the pattern of nature is a shape that curves around a center point and gradually moves further away or closer in with each turn. Like for example, this plant. As you can see, the leaves on this plant it winds around in center. So why is it called spiral? Because it is repeating curve pattern. And why those spiral appear in nature? Number one, they maximize space, like sunflower seeds. Number two, they help with growth, like shells. Shells expanding without changing shape. Three, like stream, they direct energy and movement like storms and galaxy.
So next is fractal pattern. So as you guys can see, there are plants here. And these plants have leaves. And these leaves has a fractal pattern. So first of all, let us know what is fractal pattern. So fractal pattern is a term in mathematics that means loop. Simply means infinite. So as you guys can see, these plants has infinite patterns. In other words, these plants are being formed with fractal pattern. That's all. Thank you.
Let's talk about fracture. Fracture is a separation of object into two or more pieces under stress. So fracture is also appear in art, mathematics, and science, describing complex structure and pattern. So the fracture refers to a break or crack in a object, materials, or structure. Example of this slug. The break or crack in the log was called as fracture because it refers to the physical separation of log structure.
Hello everyone, to explain what is a manger. A manger means to move or travel in the winding, indirect or contrary, either by following a purpose like a river or a road. For example, just like snake's letters, left and right in each thing.
Crack. What is crack of nature? Crack of nature is a line on the surface of something along which is a split without breaking into separate parts. Example, the floor. As you can see, there's a crack on the floor. The best example of crack of nature. A crack of nature can be likened to a crack on the floor. A line that forms as natural forces cause a surface to split. Stripes. Stripes are one of the most common patterns in nature. So what is stripes? Stripes are long lines, narrow lines, or bands that repeats side by side. So we can see them in zebra skin, tiger fur, seashells, and even rock layers. So I have here a very good example that I have. So as you can see in this t-shirt design, you can see that there is a long line, repeated lines side by side. That's why it's called stripes. That's all.
So, the last pattern that I'm going to discuss is tessellation. So first, what is tessellation? A tessellation is a pattern of one or more shapes that fit together with no laps or overlaps. So, I'm gonna show you an example of tessellation. As you can see, this style is an example of tessellation. Also, down here is an example of a tessellation. So, a tessellation is simply a tiling that has a repeated pattern repeated pattern of one or more shapes. So, not also here in this campus we can see example of representation, but also in the outside world. So, to sum it all up, our discussion or the topic that we've discussed, all of the patterns can be discovered or explored here in our world. That's all.